are back to our study room because we want to do the Gaussian. Yeah. I think on last video I said we are doing it. We stopped the Gaussian playlist because I'm doing the work with Thibaut in his office now. Unfortunately, we can't keep doing it. Well, so we are doing it from here better. We have the time to work together. Now, I like this part of the project. I like this part of the project because we are done with the math pretty much. We have too much results. We probably won't want to have a lot of results. That's enough. Paper is big enough already. What we want is now a lot of graphs, a lot of codes, and writing and finishing up the paper, which I like. So it's all good, it's all good, it's all good. Now, let's see what I can do today. Well, I draw the graph. I drew the graph for the benchmark, the maximum payment, maximum welfare, maximum everything. And we want to compare it to something else. That was kind of the goal. Let's see what I got here. Let's see what I got. Don't fall. So I'm tired. So for now, we want to focus more on the code than the proof. And now we want to compare with the first, not first best, but okay. Oh my god. Okay, we had the graphs for the benchmark, and now we want to compare it with other graphs. Yeah, let's do that. Well, for the optimal web payment, we know what's up, right? Also, for example, for the benchmark, we have graph for a lot of things. We're gonna have the graph almost for everything. For any sigma, for any payment. So we have everything. Now just let's draw the graph for other benchmarks. Meaning optimal welfare, not optimal welfare, optimal revenue. Let's go optimal revenue first, and then first best. First best and optimal revenue, pretty much the things we like the most. And then I want to use here to go to my overleaf page. Oh no. Home, okay. And let's see what other tasks do we have. Because the code for optimal revenue is already done by Thibaut. So we have the comparison of revenue in optimal revenue and the benchmark and the comparison of sigma. Well, we have these graphs. Other thing that we had based on our last meeting is that we have so many results, but there is no intuition behind them. So we wanna have a lot of graphs. We wanna have a lot of photos, pictures, figures, whatever, so that we can come up with an intuition. We want a lot. For that, we want code. For the benchmark, we have it. For the revenue, we have it. On my list here, it is just that. Also, let me go check if Thibaut has anything else. Then if you are done with that, well, some of the proofs have changed. So we had like some missions like what to do when R is outside the range -1 to 1 over n minus 1. Or the proof of the comparison of sigmas. Our result has changed since we changed the outside option. So those stuff we don't want them, but we have new tasks to do. One thing that we were thinking about, okay, we have these new results that, where is it? Mu AI depends, in the optimal revenue problem. Mu AI depends on mu theta I and mu omega, and sigma AI theta I now depends on mu AI. And if sigma AI theta I, mu AI is so big, sigma AI theta I will be bigger than optimal welfare. Otherwise, if it's small, it will be between welfare and Nash. So we wanted to come up with an explanation for this inequality that we have now. And it seems We want to plot MI, mu AI, get a better understanding of participation constraint and its effects on MI, especially proposition. So like this proposition here is not right anymore. We need to remove it. So they are fixed. Section 4, participation. Welfare is the same as before. So that's it. Actually, we are done. We don't. We just need to write the stuff down. The prepositions, we already have them. We want a lot of graphs. Because we have them. Okay, I'm looking for a new task to do. My problem is that, okay, we can't do the optimal revenue. We did it already. We did optimal revenue already. Like Atibo wrote the code. We have the benchmark already. Honestly, I don't think what do we. Let's go to the first best. Okay, if I don't find anything in 20 minutes, I will start doing the first best code. It's a simple code, good for us, warms up. Yeah, by the way, about thesis, I'm very excited. like multiple platforms matters a lot because we have like Netflix, we have all these Hulu, we have a lot of different things, and some of them have common shows, and some of them have unique shows. There is a competition among them. Oh my god. Let me just add it quickly. They don't want to be exactly the same thing, right? Because otherwise, what is their difference? And they don't want to be very far from each other, right? This was a conversation came up yesterday in our talk with Alessandro about beauty contest game, and why does it matter? Because now we have all these LLM models like ChatGPT, like Google Gemini, and once you ask them something, you want them to have something similar answer. But if they're all the time similar, then we need only one of them. So they have to be different in some ways as well. Which one am I going? Thesis. No. Gosh. Okay, let's go over the stuff. Okay, these are all old. Let's maybe even remove them. Okay, I removed this stuff. I will pause it for now. I will come back to you. Or fuck it, I will stay. Um, okay. Now that we have our notes in the overlay file, I don't need them here, so I'm gonna delete them. What is this note? Seems like a page. I can go over, read some of the proofs, check them, and if anything, okay, I think I can delete these two. Guys, you need to have bigger forearms, by the way. Um, Okay. Now, okay, I don't want to delete these. Maybe I didn't get the update from Tivo. I don't know if he worked on them or not. So let's keep them for a while. Um, so it seems it's just first best. I don't know. It seems like first best. Yeah, I can't update people of what I am doing. Also, I don't know, to be honest. I feel comparing payment is good, but comparing Sigma, we also talked about it yesterday. Comparing Sigma when comparing Sigmas when we have different mu's may not make sense, to be honest. So benchmark has a different mu than optimal revenue. Mm, Okay, let's go find first best. If it is done, if it is we are done, just I'm okay to add as many as graphs as I can. So finish this paper. Fuck it. Where is the first best is after. Why are we sitting here spending our time too much on this project? We just let's get rid of it. It's done. Comparative statics. Okay, we have a to-do checking improvement of optimal revenue, checking function. Okay, we don't want to do the mixed objective function anymore, where we had a consumer's utility as well in the objective function. We don't want that. First, okay. So there is no constraint. We have there is no constraint. Okay, this is the talk we had with Thibaut last time. what is our first bit? Oh my god. Okay, we wanna for sure, because Muse are not the same. We wanna compare revenue. I think the nicest thing to compare is revenue, not sigmas. But in first best, we don't have a revenue. First best is designed for maximizing welfare. Therefore, if you want to compare revenue, what is the payment? What should be the payment? Exactly. What should be the payment? And it brings this conversation here that I was saying, okay, to find the payment, let's assume first best is individually rational, which to be honest is a added assumption. For first best, you don't need to assume individual rationality. Therefore, you cannot say, oh, if you say your payment comes from individual rationality. Okay, this was my suggestion. If you say your payment comes from individual rationality and this is the only constraint, we don't need truthfulness, we don't need obedience, the platform knows every theta, then payment comes from UI minus UIO, and but what is UIO? What will be UIO? Because UIO, remember, UIO has an MI in it, which is part of the design of the mechanism. So what happens to you if you don't participate? Another thing that Thibaut mentioned, it was my method. So if I want to continue my method, I should find out the UIO for this first best and everything. Thibaut believed that, okay, we can have another approach. What can we say? We can say whoever participates, we don't have any participation. Okay, this, like, Thibaut is also adding assumption, because again, in first best we don't have payment. So one way we need to connect, make payment, find the payment. He said, let's compute the payment from truthfulness. So derivative of the payment comes from truthfulness What about the MI? Because CI depends on MI. CI is a constant of the payment. So this way we have both CI and MI. Which CI which is way. And so here we also have MI, by the way. And UI is okay, we have CI, MI, and sigmas. CI is the constant of the payment. UIO. So again, we need UIO, but maybe this time, okay, the point is that this time MI remains the same MI we use for benchmark, we use for other stuff. Yeah, okay, I say my method is better. Because it is simpler. Okay, not better, there is no better, it's just a matter of choice and taste, I say. Both both of them do not sound very clean. We don't have revenue well defined. Okay, the problem comes from the fact that we don't have a well defined revenue for the first best. Therefore, I like my choice better. Okay, that's why. I like my choice better because I feel it has less assumptions into it. And it is mathematically more simple. I don't say T-Bow's is bad, but just matter of taste, I say. And both ways, T-Bow's method also requires MI. So I say I want to do my own thing. Um, okay, control shift. Okay. So what I want to do now is first best, and I want to say I'm just my assumption. This is my assumption. If you don't believe in it, this is my assumption. Okay, I'm fine with that. We only have individual rationality, UI minus UIO should be greater than PI. So I will set PI as UI minus UIO. That's it. The maximum possible. UI minus UIO. What is UIO, by the way? Okay, what the fuck? So welfare didn't change, but optimal revenue, since we changed the outside option participation constraint, welfare didn't change, but revenue changed. Why? Because we have this term from UIO, and now we are doing the optimization on the constant of the outside option, MI, the constant of the payment, and the sigmas all together, and it makes MI depend on, right, and it makes MI depend on UIO, sorry, on the sigmas, sorry, alright. Alright. And now first best again just computes optimal welfare, right? So the choice of okay, if I want to set here actually, okay, so first best says I don't give a fuck about some of the PIs, I try to maximize some of the UIs. Problem is symmetric, I just maximize UI. Now you want to say what will be the payment, expected revenue in first best, right? Well, it is expected of the sum of the payments in the first best, but we don't have a well-defined payment for the first best, right? We want to compute expected of PI of F. We don't have it. My assumption helped a bit to define it, but it's not complete yet. So you want to compute expected of UI minus UIO. Well, UI is defined, right? It's all good. But what is UIO? This is the question now. We need to add one more assumption probably to complete the so it is a choice of MI, and this is actually on payment. It's kind of just CI. So I kind of set PI first, and I'm then setting UIO first. What Thibaut said was more, let's set dude, I got fat. I have fat here. Oh my god. I'm gonna do crunches. I think it's the good time to start crunch in the gym. I don't like this. Okay. The way Thibaut said it, Thibaut was like, okay, so I have two assumptions too. I need to make two assumptions too. Thibaut also wanted to make two assumptions too. Thibaut's assumption on payment, first one was to choose payment based on truthfulness constraint. And then actually, to be honest, we're talking about these two, but I believe at the end of the day, none of them add much value. You just say something and finish. Fuck it. I like this one more. I will go with this one. So he chooses PI prime based on that, but he needs to decide on CI. So both of us, and for that CI, probably he also needs to consider individual rationality. So he has to consider individual rationality, but I don't have to consider truthfulness. So let's assume that just we are going with me. We are going with me, and let's choose the MI. What is the MI? We chose the CI kind of. We chose the formula for PI. So should I choose, now that we are talking about first best, what is this MI? What MI is this? One can say, let's choose MI that is good for to be honest, I say it's just a stupid comparing payment in first best. Maybe it's better just to compare the value of welfare to value of expected payment. Even in welfare, even in optimal welfare problem, there we also have some payment. But I feel it's better to compare welfare to the expected revenue than expected payment. Let's do that. I say that's better. Let me email Thibaut. So first best. Hi Thibaut. Okay, by the way, use your phone like this. Hi Thibaut. Um, for in both cases, we have one assumption for welfare. Okay, for the formula How do you of payment and one for assumption for for side MI MI outside MI or something. Um, happen well defined payment here. Moreover, I'm using moreover in my email. Moreover, first best is not designed to study payment. I feel it is better to just compare the welfare in first best with compare the first welfare of the first best with the revenue of the benchmark. Let me know what you think. Best that's it. Good. I feel more. Yeah. We can define so many payments, then it is not a fun game to see what's up, right? You can say, oh, I could change the payment a bit more. So I say it's better to compare welfares and the revenue. They are the same units, by the way. They are not something like comparing pear and apple. It's comparing like utility and money, because we have semi-linear utility format. Once we can add and subtract utility and payment, I feel it completely makes sense to compare welfare and expected payment. Um, it's also what something we do, right? We say when we solve optimal welfare, we say we generated this amount of welfare, all right? Then we compare it with optimal revenue and say, okay, revenue takes a bit from welfare. So we are saying we're kind of comparing these two concepts. One is money, one is utility, but because our utilities are quasi-linear, I feel we can do that. Now let me do the let's go over the proof. We had Thibault added proposition 4.15, optimal revenue. Let's go over them. Let's see if something is missing. Let's try to draw curves as far as we can. I wish I could just, just like my phone is silent, right? But I wish I could just unsilence Thibault, or like, yeah. For now, I just want to receive email from Thibault. It would be nice. Because now I have to check my phone every time. Oh, did Thibault emailed or not? And it should be across all apps, right? For example, on my text, I'm okay to receive a text from Apple, but on Messenger, Costas is allowed to text me. That's the thing. Once you have so many platforms, you need to have another super platform to take over all of them. How's everything, guys? I think everything is going well. So, okay, what is the welfare? Okay, I think I need some ChatGPT, to be honest. I don't want to read all of these letters and words and characters.
File outline. Number, the mean aggregate action that a non-participating player faces. 4. I\in. N and J\nuc. I, let.
It's reading
A
the code.
because the quadratic game introduced in section 2.1 is symmetric, we will be able to show in proposition 4.1 that we can restrict ourselves to symmetric mechanisms without loss of. The covariance matrix of a symmetric mechanism has a simple structure presented next.
What about here?
Be respectively the mean vector and covariance dash. Because the quadratic game introduced in section 2.1 is symmetric, we will be able to show in proposition 4.1 that we can restrict ourselves to symmetric mechanisms without loss of the covariance.
Okay, just jumped over some lines.
Matrix of a symmetric mechanism has a simple structure presented next. Be respectively the mean vector and covariance dash.
Okay, it doesn't read the Greek letters and mathematical formulas. Better. Mu R2 n plus, okay.
And matrix of a Gaussian mechanism, with the block structure indicated in. Because the mechanism is Gaussian, it is fully determined by its means and covariance matrix. In other words, symmetry reduces the number of parameters required to specify a mech dash. Crucially, this number is independent of. Since the covariance matrix K is required to be positive semi-definite. This implies constraints on the covariance parameters as stated in the next lemma proved in. Of a symmetric mechanism is positive semi-definite IFF. 2. The following inequality constraints hold with the convention.
The covariance matrix K of a symmetric mechanism is PSD if and only if sigma I theta I, sigma I theta j is 0, sigma theta I is, okay, these are the degenerate cases, sigma theta I 0 or sigma omega 0. And if this, we have this quadratic inequality.
Furthermore, there is equality in the first inequality IFF.
Oh, the first inequality, if it is equality, it means AI and AJ are maximally correlated. So whenever first PSD constraint is binding, it means that the actions are maximally correlated. And they are maximally anti-correlated if the second one is binding.
The recommended action is a best response for each player, conditioned on their type and their recommendation.
Jumped a lot. Okay, remark. The case, why don't you read the remark, by the way?
And because the mechanism is Gaussian, it is fully determined by its means.
The remark.
Covariant remark. The case where equality holds in both inequalities is thus equivalent to var ai theta omega n 1 equals COV ai aj theta omega equals var ai theta omega.
Great remark. So we said when the first one is binding, we have a maximally correlated. When the second one is binding, maximally anti-correlated. When both of them are binding, it means both are happening and AI and AJ are deterministic given theta and omega. Okay, let's go over obedience. Let's see what are we giving.
Or equivalently, var AI theta omega equals 0. In this case, AI equals EAI theta omega AS. File outline. \item. For each player, conditioned on their type and their recommendation.
Do it here.
Recall that a mechanism is obedient if following the recommended action is a best response for each player, conditioned on their type and their recommendation. In other words, the condition I set membership symbol arg maximum I set membership symbol REUI AI theta I omega AI theta I must hold almost surely for each player. I set membership symbol N. Lemma 3.4. Assume that UI I set membership symbol N defines a symmetric game if A theta omega is an obedient mechanism, then for all permutation. Pi set membership symbol. Sn, the permit mechanism. P pi a, P pi theta, omega.
Should be obedient, I agree. Proof, consider permutation pi sigma. So for any permutation it should be symmetric, alright. Given AI theta, right. Obedience showing in particular that the recommendation means they are determined by obedience. R is not -1, R is not 1 over n minus 1. What are these two values, by the way? Okay. Oh, these two values make the K matrix uninvertible or something like that. The mean action, so obedience pins down mu AI, we know that. I know a lot of this stuff. I am going over them because I'm reviewing the paper. Yeah, why not? So the mean action is determined by, even for non-symmetric case, we have the formula. Covariance matrix, we can remove two of the variables, sigma I square, sigma Ij. We can remove them. The remaining ones are sigma I theta I, sigma I theta j, and sigma I omega. Anything else? That's it. So this is obedience. Obedience has no inequality. And then in obedience we compute expected and take the action that maximizes that. Given AI theta I, right? Maximize. So we have the formula for AI that is obedient. AI will be R, it's equation 10, J, Gaussian, we can compute this conditional expectation. Mu AI is R, okay, that's pinning down, okay. Can you read it from here for me, motherfucker? I don't wanna lose my accent.
Where the first equation expresses the equality of means in 10, and the second, RESP third, equation expresses the equality of the covariance with AI, RESP theta I, in 10. To compute the covariances, we used that COV E X.
This is something about Gaussians.
Z equals COV X Z for random variables X, Y, Z such that Z is Y measurable. Writing the first equation in 11 for each player. I set membership symbol and gives the following linear system in mu AJN 1R mu A equals S mu
This is the
omega
equation
1
we got from the
n plus T mu theta. Solving this system using proposition D.7 yields the first half of the obedience characterization. The second and third equations in 11 give the second half of the characterization. Remark 3.6. For symmetric mechanisms, expressions 8 and 9 are the same for each player. I set membership symbol N and simplify to mu AI equals S mu omega plus T mu.
So for the Nash, we computed the Nash equilibrium of the complete information game. Complete information game. Everybody has every information. Is the Nash equilibrium, it is not an obedient mechanism. Why is it trivially obedient? Because once you know AI and theta I don't get I don't have the Nash equilibrium. Base Nash equilibrium, yes, it should be obedient for sure because they do it. But why complete information Nash? Oh, okay, I can tell you. Complete information Nash equilibrium is also obedient because once you have all the information as a player, you will also take an action that is a linear function of theta j's, theta I, and omega. And once you are assume platform sends you the same action, you will take it. That's right. So base Nash, you have no information. Platform tells you to take the action that you already want to take, you will take it. All information, you assume you have all the information, you will take this action anyway. So it will minimize, maximize your utility. So it is obedient. Or if you know that platform is giving you all the information, you would be taking that action. Yeah, it is obedient. Mm-hmm. Example 3.8. Base Nash is also obedient. Sigma AI omega, yep, 0 AI. Theta J is also AI J 0, AI theta J 0, AI theta I we have. Because you know your information and it is the only information you're taking. And it's, yeah, sigma AI theta is just AI is fully a function, linear function, a fine function of theta I. AI is deterministic given theta I. Okay, now let's go over truthfulness. Obedience sounds fine. We could compute expected UI in obedience. That was some formula that we need. And it comes from the formula in the first section or second section. Exactly, from the utility formula. Truthfulness.
In this section, we focus on characterizing the truth-telling constraint of mechanisms. This is a relaxation of incentive compatibility that only accounts for one-shot deviations at the first stage of the game, i.e., the reporting of types, and will serve as a useful baseline when we turn to full-blown incentive compatibility in the next section. Define UI, theta I, to be the interim utility of player I when they report their type, theta I truthfully.
think we agree, yeah. We'll start, and then we'll that is one difference on half of a person self-indicative of a problem we had similar. Alright. Yes. Yeah, okay. Yeah. Mm. Thanks. Yeah. Okay, thanks. Counter argument. Mm-hmm. Okay, thanks. Okay. Um, yeah, I agree. Okay. Mm, okay. Yeah, I agree. So Thibaut here says like the question we wanted to study this benchmark to find to what extent obedience is limiting us, obstacle to maximize the objective we care about. No. Um, thanks for reminding the question. For the benchmark. Um, benchmark. Okay. Yeah, welfare. Yeah, it's better to compare welfare with revenue, but comparing first best with the benchmark on something for revenue seems too much. I agree with Thibaut. No, they are benchmark. Uh, yeah, 2 points. Um, mm, uh, image motion. Um, right? Uh, uh, Hello. Wait, guys. Let me pause. Okay, guys. Yeah, let's compare just benchmark with the revenue. We have the graph for the revenue. We have the graph for the benchmark. Do we want to put them next to each other? That's a question that I can ask. Is it something we want to do? The thing is that for the benchmark and for the revenue, the range of R that we are defining are quite different. By the way, let me update my notes because Thibaut had a point. So one is comparison benchmark with optimal revenue. Maybe the thing we can do is just putting the graphs next to each other. It's not a big deal, to be honest. Two, comparing welfare, effect of obedience on welfare. Let's talk about it like this. Effect of obedience. How much obedience is costing the platform to generate welfare or to generate revenue? Comparing what is it? Comparing welfare in benchmark TWO, truthfulness without obedience for welfare. Which Thibaut said it is just, Thibaut says it is first best. So it's interesting. What does it mean it is first best? So when players follow your recommended action, it means that, so the difference, we have truthfulness, we have obedience, we have like instant IC in general, which is welfare, optimal welfare, and we have first best. The benchmark says let's remove obedience, let's assume the players will follow whatever we tell them and see what's happening. And Thibaut says this is actually the first best, which means once players follow the action recommendation to optimize the welfare, they will be truthful too. Okay, let me take email here. Okay, Siwa says we need to explain it. Mark. Really? Okay, that's also done. Okay, So maybe if Thibaut has a proof, that's it. If he doesn't, we can spend some time on that. Okay, now we want to go over truthfulness. Yeah, I feel like I have to go over the paper another round. If there are some small questions left for me, I want to do it now.
And, in this section, we focus on characterizing the truth-telling constraint of mechanisms. This is a relaxation of incentive compatibility that only accounts for one-shot deviations at the first stage of the game, i.e., the reporting of types, and will serve as a useful baseline when we turn to full-blown incentive compatibility in the next section. Define
Full-blown
UI, theta I, to be the interim utility of player I when they report their type. Theta I truthfully.
So UI tilde of theta I is the interim utility of the player, which is expected utility of you once you observe your type, right? Exactly.
And follow their action recommendation at the second stage of the game.
Okay, we are assuming truthfulness, only truthfulness, so we assume that players are obedient. Once they receive the recommended action, they will follow.
They report their type, theta I truthfully, and follow their action recommendation at the second stage of the game. UI, theta I, equals EUI, A, theta I, omega, theta I. The following proposition gives a characterization of truth-telling for Gaussian mechanisms. 10.
Speechify is a bit okay, this I can read it myself. A Gaussian mechanism mu kp is truthful if the mechanism is truthful if for each player. So we have this inequality t sigma I theta I. Yep, we should have it. Why should we have it? So that we make sure the yeah, okay, where does the truthfulness come from? We have this saddle point inequality or something like that, that we want the function to be convex, right? So we write it once for theta I, once for theta I prime. We sum this stuff together. We have the derivative of pi of theta I, but because it comes from this envelope thing, tangent line, we want the function be convex or concave, and that one gives us this inequality. So the derivative of the payment function, once we have truthfulness as a constraint, is, I should talk louder, sorry. Once we have, I need to buy a microphone too. Pi prime of theta I, pi prime of theta I. So, okay. These are some scratch stuff I'm writing here. Pi prime theta I is ui tilde prime of theta I. Don't forget, ui tilde of theta I was the interim utility. Once you report your type truthfully, and you will follow the recommended action. Dude, I am getting fat. Minus t. I think now just, yeah, the game has changed, guys. I recovered my I'm recovered from my injury like 90%. I think slowly I can start doing abs workout. Like I'm doing a lot of core workout like in PT, but like doing crunches, I think crunches are not good for it. So we can do like a like a very light crunch workout so that I can see the six pack. I want to see it. UI tilde prime of theta I minus t expected of AI given theta I. That is it. That's the formula, but we have UI tilde I prime. UI tilde I prime. Now we have Vi of theta I theta prime, which is what is your utility if you follow the recommended action, but you can lie theta I prime. I want to also change this cost to, because cost is a term we use for core no, cost no, but type. Report theta and follow the recommended action at the second stage of the game. So okay, expected of UI given a should be a because you are following theta I prime. So then we have the utility given theta I, but given theta I prime, all of them are independent of theta I, except the theta I itself because you know it. Yeah. Exactly. Exactly. So it will be UI tilde of theta I prime plus, okay, this is a nice formula that results in the derivative of the payment. Derivative of the payment. Alright. Let's finish this and then we will take a break. So we have this. So we have this UI. Now we will do it the same thing for the theta I and theta I prime, right? Vi minus pi of theta I prime. UI theta I prime. Okay, this is the, is it saddle point or whatever it is? This greater than, once your type is theta, truthfulness wants us to be truthful. So once your type is theta I, you should telling the reporting theta I prime should hurt you, not benefit you. So the direction of this inequality is the other way. So this is the function at theta I prime equals theta I, and on the left hand side we have a linear function of theta I. So we have a function of theta I on the right hand. Okay, I should change this direction for sure. So this function of theta, we have a family of linear functions, affine functions based on theta I. They are all smaller than what is LQ? Less than, not smaller, less than or equal this function of f of theta I, which is ui tilde of theta I minus pi of theta I. And at theta I prime equals theta I, they match each other. So if you have a bunch of linear functions, right? All of them at point theta I are equal to the function we have, right? You have a convex function. All of these points, all of these affine functions are passing through that point and are tangent, or they're not tangent, they're below the main curve. And at theta I prime equals theta, it is tangent. All right. So the function is convex, and the derivative is given. Convex, exactly. So by that, once it is convex, the derivative should be increasing, not decreasing. So we have the formula for net utility derivative, which is t expected of ai given theta I, and we can compute the conditional expectation of ai given theta I. Let's see, if Tibo emailed. Expected of ai given theta is mu ai sigma ai theta is. And this motherfucker should be non-decreasing t times this. So the derivative of this is t sigma ai theta I over sigma theta squared, should be non-negative. Exactly. Okay, it's a good point to go for a break. I'll be back.